Hey MMT followers, Christina Fugis with Mold Making Technology and another quick MMT chat. This time on simulation. Today my guest is Mark Howards, who's the founder of 3D Shapes. He is a mechanical engineer and he's also an Autodesk Mold Flow certified expert. So Mark, why don't you share a little bit about who you are, your background, before we get into simulation?
Sure. Well, thanks for having me on. Well, my background is mechanical engineering, and I spent most of my career involved with injection molding. I got my start doing plastic part design quite a long time ago, back before all the good 3D tools were available. So I ended up working at a company that actually had a plastic simulation product. It was a company called GraphTech. And then I got the idea of starting my own company back in 1992. And that was kind of involved with doing a lot of complicated surface modeling and product design. And one of the first things I wanted to do was bring in a plastics analysis package. Brought in C-Mold, and I've kind of been doing plastics analysis ever since. All the way from back then, the software's been pretty accurate, but what's happened over time is just the capabilities have gotten a lot better. And probably, just the ability to analyze a lot of different things that you couldn't do back then.
So like any technology, just improves. You stuck with it long enough because it really seems like a passion of yours. I can tell when I speak with you. So why don't you talk a little bit about some typical problems that you see when you're working with customers?
Well, typically people will ask, a lot of the common questions are about fill pattern, pressure, clamp force, that sort of thing, or maybe where to gate apart, how to get the knit lines where they want them. But I also tend to see lots of problems with non-uniform shrinkage and high shrinkage in parts. That's very, very common. And a lot of what happens with that is a lot of warpage issues, issues with sinks and voids, that sort of thing. So a lot of these things can be dealt with a lot easier if they're discovered early on, but it's common not to do the analysis a lot of times until the problems actually crop up.
It's that fix it rather than prevent it mentality, right?
Yeah, pretty much. Unfortunately, the problem with that is when you discover a warpage problem and you have a part in your hands after you've molded some samples, it's kind of hard to figure out exactly what the cause of it is. And that's really one of the places the analysis comes in so handy, because rather than just looking at dimensional issues, you can look at pressures, temperatures, packing problems, and actually get to the root cause of the problem.
You end up seeing a lot more.
Yeah, I mean, an example of that was something I worked on fairly recently. And if you look at the part, the problem was obvious. The symptoms of the problem were obvious. It was an issue with sink and voids. A common way to fix that sort of thing, depending on the part, might be to open up the gate and try to get better packing with the part. So they had done that a little bit and still continued to have problems with the part. So I went in and did some analysis because they were thinking about making it even larger. And what the analysis showed was the area between the void and the gate was actually freezing. So it didn't matter how large the gate was, you were still going to have a problem. And, I suppose you would find that same problem, you'd figure that out yourself. You keep increasing the gate size, get better results, but it's kind of a waste of money to be making those changes and you're losing all that time in the process.
Exactly. Why do these problems happen? Why do they occur? Are there strategies or things people can do when it comes to designing a part?
If every part and every tool was designed just based on rules of thumb and what everybody would like to do, then you never would have problems. But unfortunately, every step of the way there are compromises. There's some of probably the most common thing that happens with the parts themselves is they don't have uniform walls. I mean, there's so few injection molded parts that actually have uniform walls, unless there's something very simple. And that causes all kinds of problems with packing. I mean, just what we were just talking about, shrinkage, warpage issues, they're all related to that. Things like properly designing ribs and features, even something as simple when you're designing a tool of putting the gate in the thickest area and having the part fill out to the thinnest area. Sometimes they just can't do that for other reasons. So through that process, there just end up being a whole lot of compromises because you've got the part issues, you've got the tooling issues, and then you've actually got the molding machine you're running it on, whatever limitations you have there. So you've got also process issues. All those things come together. And a lot of times there's just a lot of unanticipated problems that end up occurring.
So simulation sounds like it's that tool that as long as you use it at the right time, right, the earlier the better, you can avoid a lot of those problems. But why do you think companies, it seems obvious to me, why don't they?
Well, I think because, you know, it's true. The best time to use analysis is early. And then ideally, you'd like to be able to use it for every step of the way. So you do some early analysis, maybe figure out you have some issues with some thick sections, make some changes, get into tooling. So you pick gate location, maybe use it to help you with the cooling layout, that sort of thing. And even, you know, get to the point where it helps you to develop the process before you're actually molding parts. But I think a lot of companies end up doing similar parts, or they've had experience with something similar in the past, and they all obviously all have a lot of expertise. So why anticipate the problem? I mean, it's kind of human nature to not to kind of react to a problem instead of try to plan for it up front. And so I think that's just where a lot of this sort of thing happens, is some small issues that come into play, some small changes, or some things that are different from parts they've done before, and the results don't end up being the same. Sometimes the problem is that even the solutions don't end up being the same, because, you know, if you've seen a lot of these things before, you might have an idea, for example, what I just said before about gate size or some other simple solutions, and they don't end up working because there's something about the part that's a little bit different, or something about the way the tool was built that's a little bit different. And it's just not always obvious.
So experience is awesome, right? But it's not always going to give you the answer that you need. That's why we have these technology tools.
Yeah, and unfortunately, I think the experience can get in the way of doing analysis to some degree, because first of all, if you haven't had analysis done before, or if you're unfamiliar with some of the terminology or even what to ask for, you know, if you've been in the business for 20 or 30 years, and then all of a sudden you want to do this, you know, sometimes you don't even know what questions to ask. And I see that a lot of times. Even when I'm doing reports on things, you know, on different projects, because the terminology for mold flow is not always exactly the same as for molding. And, you know, sometimes people are a little bit hesitant to say what they don't know or what they don't understand. So I try to make it a point when I do the analysis and when I'm doing the reports to try to stay in contact with them and try to make sure they actually understand what the results are showing them. And something like warpage analysis, that's fairly obvious. So if you're looking for filling analysis, or, you know, just a melt front advancement, most people understand what that's all about. But when you get into things like volumetric shrinkage, which is a really key result for mold flow, it tells you so much about packing and the quality of the part. But if you haven't worked with the analysis, with an analysis package, you might not really understand what that means. Other things like shear stress and shear rate, which get confused all the time, that is not something that a typical molder is going to be talking about on a daily basis. But if you're getting analysis done, it can tell you a lot about how to solve problems with the parts.
How can people reach you?
Well, best way is to give me a call. People are doing more of that these days, I think.
That's true, right?
Yeah, it's 781-789, excuse me, 3380. But also you can do it the old-fashioned way, 3dshapes.com. Just send me an email.
And I want everybody to know out there that Mark has been working with me to produce some articles. So there is one out there on core shift analysis right now. So check that out. And I know he's working on a few more for me. So look for his name and please provide comments and reach out to him. And Mark, thank you for your insight. If anybody want to reach out to me, cfuges@gardnerweb.com if you have any questions or ideas. And other than that, for everything mold making, visit moldmakingtechnology.com.